The best way to learn a scientific concept is to do it yourself. Learn by doing and you'll understand. My name is Alec, and today I will demonstrate one of the most valuable, important concepts to science, energy. Energy is defined as the capacity of a system to do work, and this capacity to do work is one of the most important resources we have. Here are the required materials for this demonstration. I'll need one hand generator, 2 alligator clip leads, one black and one red, one cluster of about 6 clear incandescent Christmas tree lights, one cluster of about 6 white LED Christmas tree lights, and lastly, infrared goggles. Here are the steps for this demonstration. I will start with the incandescent light bulb. First, I will attach the alligator clip leads to the 2 nails, these are called electrodes, on the hand generator. I will attach the black clip lead to the top nail, or electrode, this is the negative end, and then the red alligator clip lead to the other nail, this is the positive end. Next, I will randomly choose, because the direction of current flow is not important for incandescent bulbs, one end of the incandescent bulb cluster is marked positive and the other negative. I shall hook these ends up accordingly. Before I crank the hand generator, my partner over here will visualize with infrared goggles the light bulb's emission of light, or energy. I shall now crank the hand generator for the incandescent bulb. As you saw, while I felt, I had to apply a lot of force or strenuous work to power this incandescent light bulb. As a result, we say that incandescent bulbs are less efficient in terms of productivity. Also, my partner saw through the infrared goggles that the incandescent bulb emitted more scattered infrared light or wasted heat energy than the more focused visible light. Since there is more infrared light, meaning less focused visible light, which we want, incandescent bulbs are less efficient. Now, let's look at the LED light bulb. We need to hook up the LED bulb accordingly and not randomly like the incandescent light bulbs, because the direction of current flow is actually important for LED bulbs. I will attach the red lead to one end of the LED bulb cluster marked red and the black lead to the other marked black. Again, my partner will visualize with infrared goggles the emission of light. I will now crank the hand generator for the LED bulb. Notice, as opposed to the incandescent bulb demonstration, this LED bulb demonstration is very different. Powering this LED light bulb was not as difficult. I did not have to apply as much force or work to power it. As a result, we say that LED bulbs are more efficient in terms of productivity. In addition, my partner noticed through the infrared goggles that the LED bulb emitted more focused visible light than the scattered infrared light. Since there is more focused visible light, meaning less scattered infrared light, LED bulbs are more efficient. Now, let's analyze these observations explaining the light emitted and the work applied. The conclusion: although both bulbs are equally bright, one bulb, the LED bulb, gives off more focused visible light or productive useful light for human use than the other bulb, the incandescent bulb, which gives off more scattered infrared light called wasted energy. The bulb that yields more focused visible light is the most efficient. That is the LED bulb. As our last proof, we know the LED light bulbs are obviously more efficient than the incandescent light bulbs because of the amount of mechanical energy, or work, I had to input. The LED light bulbs required the least strenuous work, cranking the generator was easier, so it is more efficient. We have now finished our proof. The implications of this old experiment are vast. Imagine if I could apply an even greater force to power all the lights of, say, a city. We can already do that. Engineers have built powerful wind turbines, which many of you have already seen, and they're very similar to hand generators. Let's not stop there. An even greater, better, and more efficient way to power, say, cars is solar panels, which provide unfathomable amounts of sustained energy. Do you have any other ideas? Perhaps you can invent that new technology and change the world. In this experiment, the useful energy, not the energy lost, powered the light bulb. And so the light bulb that required the least amount of work was the most energy efficient. And that light bulb was the LED light bulb. This activity illustrates how you and I are always interested in energy efficiency. That is, the energy that is useful, not the energy that is lost. It also demonstrates how in the real world, society as a whole is always interested in energy efficiency, whether it's designing cars or building rockets to go to Mars.